This is the bar I've owned for the last 2 years. While serving drinks and socializing is a pretty great job, do you know what the most frustrating part about it is? When customers leave but forget their credit card at the bar. It's pretty much a lose-lose situation for everyone involved. Wired has given me 1 week to figure out how to stop people from leaving the bar without taking their credit card. We're locked on, and it's gone. By the way, I'm Mark Kleeb. I'm a creative technologist based in Brooklyn, New York. I've been building custom arcade machines for local independent game developers. In 2019, my wife and I opened Wonderville, a Bushwick-based bar and arcade that's filled to the brim with those games. There are 3 main goals I have for this project. 1, figure out the best location tracking technology to install at the exit of the bar. 2, to be able to determine when someone is leaving without their credit card. And 3, figure out how to somehow get their attention and prevent them from leaving without it. So here's the plan. Once I determine the best technology to use, I'm going to install a location sensor by the door. Whenever someone opens a tab, I'll trade them some kind of location tracker. Then, I'll program the sensor to only go off when someone tries to leave the bar with the tracker. I know some of you might be thinking, well, what if someone wants to go outside to have a cigarette? Well, we have a backyard. They can go out there instead. Finally, when the sensor goes off, I want to build some kind of display that does whatever it needs to do to stop them dead in their tracks. The first thing I'm going to need to do is figure out which location tracking technology is best for this project. I've narrowed it down to 3 different types of technology: GPS, Bluetooth, and RFID. Let's start by taking a look at GPS. So this is an Adafruit Feather microcontroller with a GPS add-on. And what this allows me to do is use a computer to write code to basically use this GPS to communicate with a satellite. If I receive a transmission back, I can determine my latitude and longitude anywhere on the globe. So I plugged in the GPS module and I brought up some example code from Adafruit on parsing serial data. So I get the time, I get the date, and it's accurate, right? However, I'm not seeing latitude and longitude because I have fix 0. I'm not getting a fix. And that's probably because I'm in this windowless box where I don't have any access to a satellite. So the next step is to go outside and see if it works outdoors. All right. I've got a fix, 40.41 north, 73.55 west. We're locked on. Let's see if this works when I bring it inside. Still got a fix, and it's gone. I think the GPS is only gonna work outside with a clear path to the sky. As soon as we come inside, we lose the connection. I think we can safely rule out GPS as a tracker for this project. Now on to Bluetooth. This is another Adafruit board. This has a Bluetooth module built in. So what we're gonna do is program this to be a Bluetooth beacon, a device that emits a Bluetooth signal. So I can use a Raspberry Pi computer with a Bluetooth module built in to sense if there are any Bluetooth beacons in the vicinity. I think this can work really well because we can install the Raspberry Pi near the door, and if the beacon gets close, it can trigger the sensor. I found some example code to transform my Bluefruit Sense into a beacon. This is a valid beacon packet. So this is what's gonna be transmitted. I'm gonna get the ID, the major and minor, and the RSSI. This is my received signal strength indicator. So I'm gonna need to set up a Bluetooth receiver and take a look at the RSSI value to determine how far away it is from the receiver. Theoretically, I should be able to find a threshold number where this is right under the doorway and trigger the display when it hits that decibel level. I've got my beacon already plugged in and working. I've got my Raspberry Pi here. Let's run this code and see what happens. So I've already got a beacon working, right? And if I zoom in here, you can see the RSSI is around -45. And so it's roughly 12 inches away. The next thing I want to do is plug this into a battery and see if I can get a wider range of signal strength just so I can determine if this is a viable solution. All right, I'm down here in the arcade with my mannequin friend Manny. He's gonna act as my customer with a Bluetooth beacon tracker. Got him attached to a chair with a dolly. I've got a rope that goes all the way up to my workbench, and we're gonna monitor the signal strength as I pull him closer. So I'm just gonna tape this beacon, and I'm gonna pop upstairs, and we're gonna check out the RSSI. Okay, so we got Manny as far away as we could possibly go, and we're getting an RSSI of about -90, far more than we could get in the booth. So let's pull him closer, and I'm just gonna monitor this value and just see how it changes. 80, -80, -78, -75, -77, and we're at about -75. So we're getting about a change from right up to the Raspberry Pi. We were seeing -40, all the way across the room, -90. So I can kind of calibrate distance now using this signal strength value. So Bluetooth works. This beacon, I can detect when it's close, I can detect when it's far away using the signal strength. What I don't like about it is that it needs power. So I need to make sure the batteries are fully charged, and whoever's carrying this around, if this dies, I lose track of them. So it isn't great for that reason. If it came down to it, Bluetooth would work. I could make this work, but I want to see how RFID goes. RFID, radio frequency identification. This is pretty ubiquitous if you've ever used an Easy Pass. Those things that are on clothes if you try to walk out with them. So what I've got here is a SparkFun simultaneous RFID tag reader, and it's attached to an Arduino Uno microcontroller. The RFID reader will transmit on a certain wavelength, and when a tag is within range, it will receive a small amount of energy from that wavelength and transmit back. And if it's within the range of the RFID reader, it can trigger the sensor. This tracker isn't powered. This is just an antenna. And how it works is the RFID reader transmits radio waves that travel through the air and can magnetize and power this to send a small signal back to the reader. That's how we can identify where this tracker is. So I've got some example code here that came from the SparkFun website, and then I'm gonna pop open my serial port, and it says press a key to begin scanning. All right, so there's no RFID tags in the vicinity, and because it's 5 decibels, I probably won't see anything for more than a few inches. Let's see if I can get these both in the shot at once. I have my tag up here. I'm gonna slowly bring it down, closer, 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 and there it is. So I can see my tag data when I'm within maybe about 2 inches of the antenna. So unlike Bluetooth, I don't get a range. I only see the tag or I don't. So we know that this works from a few inches away. If I want to extend the distance, I'm going to have to install an external antenna. And we're done. So I've rerouted the antenna to go out through this external antenna, which is gigantic, but hopefully will give me the range that I need. Let's do a range test. I'm gonna go back to my same example that I just used before, and let's take this 5 decibels, and you know what? Let's just double it. We'll see what we get at 10. So I'm gonna upload this code. If 5 decibels reads from 2 inches away, 10 decibels should theoretically work at 4 inches. Let's see how far away this will work. I'm already getting values right about here. And this is like 18 inches. This must be reading on a logarithmic curve, which means that the higher the power, the distance will increase logarithmically rather than linear. Let's go back to Manny and we'll see if we can get this to trigger only when he gets close to the antenna. Same thing we did with Bluetooth. I've got an RFID tag here. We're gonna stick it on Manny. I've installed the antenna on the ceiling, and we're gonna pull Manny in, and hopefully when he's under the antenna, I can track the tag. Okay, we're gonna start scanning, and I'm gonna reel Manny in. Right now we're not seeing anything, but hopefully when he passes under the antenna, we can see the tag. And we got a tag. As soon as Manny passed directly under the antenna, I got a tag to show up. So this is still pretty far away, but it will work. We'll just have to recalibrate it when it's above the exit. Out of the 3, I think RFID is the most promising for this project. The tags are just a piece of paper. I can affix them to something that the person can wear or carry with them, and it seems to work from many different distances. So I'm gonna go with RFID. Now I just have to refine it. Next up, I'm gonna start working on the display. So, here's my plan on how I'm gonna get people's attention when they leave the bar. This is the door to the bar. I'm gonna install a sign, gonna kind of look like a stop sign, that's gonna attach to the door. And it's gonna say, close your tab. And I'm gonna align this with LED strips. So if they try to leave, the RFID will go off, it'll light up this sign and they'll see it before they leave. I also wanna have a sound component. So I'm gonna install speakers on either side of the door. And we're gonna place some sort of alarm so that they know something is wrong if they try to leave. Okay, so I designed this file and my intention is to cut this out of plywood on a CNC machine. So I made it in the shape of a stop sign. Because it's being cut out of wood, I needed to use a font where everything would be attached so that none of the letters would fall out. I'm here with my CNC machine. So a CNC machine is a computer-controlled cutter. I've got a wood router attached to these motors, and I can take the file that I designed and it will cut it out of a sheet of plywood. So the router, I'm gonna turn it on, and it's gonna move on the X and the Y and the Z axis. It'll look at my letters, it'll cut them out, and then it'll lift off and move to the next letter. And it'll do this in a couple passes, so it's not too heavy on the router bit. Once the CNC machine finished, I sanded the sign down, cut out some wood strips, and glued them to the back. My plan is to attach LED strips to the back of the sign, so the wood strips are there as a place to affix them. It also creates some distance between the door and the sign so the lights can illuminate. And finally, I added some diffusion on the front. I don't want people to be able to read the sign until it lights up, so the diffusion will help to hide the letters. So after some testing, the LED strips weren't really shining as brightly as I would have hoped, and you can't really read the letters. So instead, I'm gonna go with this super bright LED panel. Yep. So this is gonna look a lot better when it's mounted over the exit. It's a little bit darker, but here's the final display. Now on to the speakers. So I wanted to play a really jarring sound when someone tries to leave the bar. So I did a little bit of searching online and I think I found the perfect one. So I put the siren sound on this MP3 player, which is plugged into this amplifier, which is then plugged into this speaker. So I have the siren playing on a constant loop, but you can't hear it because the amp is turned off. This means that when someone walks under the sensor with the RFID tag, all I have to do is program it to turn on the power and... All right, got the display finished, got the speakers set up, so now all I have to do is get everything working together. So I found some code that plays a sound on a buzzer when an RFID tag is near. So what I did was I added an LED because I figured if I can play a sound on a buzzer, I can also turn an LED on. I commented these lines out because I don't need the buzzers anymore, but I added this line of code that just turns an LED on when it searches and finds a new tab. So if I start scanning and I bring an RFID tag close to the antenna, I can turn on the LED. Now that I know that it works, I'm gonna replace the LED with a power relay. So a power relay is essentially a power strip, but it has an input for a 5-volt on-off switch that I can control from the Arduino. So similar to how I can turn the LED on and off, I can turn on and off this power strip. So I've plugged my display and the amp and the speaker all into the power relay. When the RFID tag gets close to the antenna, let's see what happens. So I've programmed everything to turn off after 10 seconds so we don't have a constant siren going off. This also will reset the code back to its original state so we can keep scanning for more tags. Next, I need to work on how I'm gonna actually hand the RFID tag to a customer when they open a tab. So I've got these cool snap bracelets from the 90s, and I was thinking I could attach the RFID tags to these. So I put one on and check this out. The sensor is no longer recognizing the tag. Next, I got these paper wristbands, but these didn't work either. I did a little bit of research, and I think I discovered the problem. We're using ultra-high frequencies for RFID transmission. Inside the snap bracelet is a piece of metal. Metal interferes a lot with wireless transmission. So if you attach the RFID tag to this, it's not going to read very well. Similarly, on the paper bracelet, the human body is mostly made up of water, and watery objects also cause a lot of interference. So unfortunately, neither of these is going to be a great option. So ultimately, the solution that worked was taking a little bit of foam and creating some distance between the RFID tag and the paper bracelet. This foam is about 1/8 of an inch thick, it's adhesive, so it was really easy to attach, and it works perfectly. If I was going to actually implement this in the bar, I'd probably have to come up with a more elegant solution, but since tomorrow is my last day working on this project, this will have to do. Okay, so the installation is pretty much done. All that I needed to put in the exit are the speakers, which I mounted here, the antenna, which is right over the doorway, and the display, which is hanging on the door. I had to find a pathway to outside the exit so I could run all the speaker wires, the antenna cable, and everything to this wall, where I've got the actual RFID reader, the power relay, the amplifier, the iPod, and the power for everything. So now that we're installed, all I need to do is fine-tune the range of the antenna so that when someone walks toward the door, everything goes off at exactly the right time. After testing it out, I think 15 decibels is what we're gonna go with as far as the range. The sweet spot to trigger the sensor is right about here, just before they walk out the door. Range is set, everything's installed. I got my wristband. I think it's finally time to give this a shot. Let's go. So I think it's working pretty well. It's going off at exactly the right time, just before they exit the door. The lights are going on, the sound's going on, and you know, it works exactly as I would have hoped. So the true test is going to be to try this out on someone who doesn't know what's coming. So there we go. I think we can safely say no one's going to leave the bar and forget their credit card. Overall, I'm pretty happy with the amount I was able to accomplish in just a week. In terms of practicality, I'm not sure this is something I'm going to install long term. The alarms are a little jarring, and I don't want it to seem like someone's shoplifting. But I think it's a cool experiment, and I think the customers are gonna have some fun with it. I had a great time building this project. It was really fun to work with the different technologies. Maybe everything didn't go exactly as planned, but that's part of the process and part of the fun.